Welcome to Networks Professionals.
Welcome to The Explainer. So today, we're tackling one of the most fundamental dilemmas in the entire world of enterprise networking. For years, network architects have essentially had to make a really difficult choice between two things: blistering fast local speed or intelligent pathfinding. You usually couldn't have both in a single, highly efficient package. But what if you absolutely refuse to compromise? What if your network demands the absolute maximum of both worlds? Well, grab a notebook, because that is exactly the problem we're solving today by unpacking a truly revolutionary piece of enterprise hardware.
Okay, here is our roadmap. First, we'll meet the Layer 3 switch, then look under the hood at how hardware beats bottlenecks. Next, we'll cover its network supercharging features, host an ultimate showdown with the traditional router, and finally, look at real-world deployments. Let's get started.
Section 1. Meet the Layer 3 switch, refusing to compromise. In traditional networking, you usually have to accept a pretty frustrating trade-off. Layer 2 switches are incredibly fast, but honestly, they're kind of dumb. They only really know how to move traffic locally. On the other hand, routers are incredibly smart, right? They can navigate complex paths across different networks, but traditionally, they process all this in software, making them comparatively slow. It's the classic brains versus brawn dilemma, which leads us to this ultimate networking question. How do you actually get router smarts at switch speeds? For a long time, the bottleneck was basically the villain of our story. You'd have this lightning-fast local traffic just slamming into a massive jam the second it needed to leave its local segment and be routed somewhere else. The network was literally only as fast as its slowest software processing link. And that brings us to the hero of our explainer. A Layer 3 switch is an enterprise networking device that perfectly combines the rapid data transfer of a traditional Layer 2 switch with the intelligent path selection of a router. It overcomes those old standard switch limitations by actually inspecting destination IP addresses. It then routes that traffic across different network segments, or VLANs, but it does it at incredible hardware-based speeds. It is the perfect marriage of brawn and brains. Section 2. How hardware beats bottlenecks under the hood. So to really understand how it achieves this without grinding your network to a halt, we have to look at its secret ingredient: hardware routing. Layer 3 switches use dedicated ASICs, application-specific integrated circuits. Basically, these are physical chips built for one specific purpose: routing packets blazingly fast. Contrast that with traditional software-based routers, which rely entirely on their CPU to process everything. When a software-based router gets overwhelmed, you hit a nasty CPU bottleneck. But with ASICs, the routing logic is literally baked right into the silicon, entirely bypassing that software sluggishness. It's a real game changer. So how does it juggle these two roles at the same time? Well, it maintains a brilliant dual nature. For local traffic within the same subnet, it just uses traditional Layer 2 switching, rapidly forwarding data using MAC addresses. But simultaneously, it maintains IP-based routing tables. So the second data needs to cross over into a different subnet, the switch instantly looks at the IP address, consults its routing table, and determines the absolute best path. It handles the local and the remote seamlessly. Section 3. Supercharging your network features. The superpowers. With this heavy-duty hardware in place, we can officially and happily say, rest in peace, router on a stick. For those of you who know the pain, traditional setups required routing traffic all the way out of the switch, up a single cable to a router, and back down just to talk between VLANs. It was a massive bottleneck. The Layer 3 switch uses Inter-VLAN routing to completely eliminate this. All that traffic between different VLANs is now routed directly inside the switch itself. No more single cable traffic jams. But hey, the magic doesn't stop at simple local routing. These devices support advanced dynamic routing protocols. We're talking OSPF, EIGRP, and RIP. Because of this, the switch allows your network to be incredibly resilient. If a link goes down or the topology changes, the switch just automatically adapts. It communicates with other devices to find new paths without any human intervention required. It just figures it out. And of course, sometimes you don't want dynamic adjustments. Sometimes you need absolute, rigid control. That's exactly where static routing comes in. Administrators can manually define specific routes to ensure secure, totally predictable traffic management. Furthermore, these devices offer incredible port flexibility. You can actually configure the physical ports right on the box to act as either standard Layer 2 switch ports or as fully routed Layer 3 ports. It gives you the ultimate blank canvas to architect your network exactly how you want it. Section 4. The Ultimate Network Showdown. Layer 3 switch versus traditional router. Now, you might be wondering, with all these router-like features, why do traditional routers even exist anymore? When we put them head-to-head, the dividing line becomes super clear. A Layer 3 switch is purpose-built for high-speed local routing, whereas a traditional router is your gateway for complex WAN connections. The switch absolutely wins on sheer hardware-based speed and massive Ethernet port density, but the router is essential for highly diverse WAN interfaces like T1 lines or complex fiber connections that the switch simply isn't built to handle. They have two very different but very necessary jobs.
Section 5. Where do they live? Real-world applications.
So where are we actually deploying these heavy hitters? Well, you'll find them acting as the absolute backbone in three main areas. First up, campus networks. When you need to connect different department buildings or floors where localized speed is absolutely critical, Layer 3 switches are there. Second, data centers. Imagine massive amounts of server-to-server traffic, what we call east-west traffic, crossing different subnets constantly. Only hardware-based routing actually keep up with that kind of volume. And third, large enterprises use them to massively simplify their topology. They're replacing those complex multi-device setups with a single, highly capable tier of Layer 3 switches.
Which leaves us with this final thought to consider. Is your network relying on yesterday's software to route tomorrow's data? As our data needs continue to grow exponentially, eliminating bottlenecks isn't just a nice-to-have anymore, it's a necessity. The Layer 3 switch proves that when you perfectly combine speed and intelligence, you really don't have to compromise at all. Thank you for joining me for this explainer. Keep learning, and I'll catch you.
Thanks for watching.